Okay, today we're going to review adding and subtracting expressions with like radicans. Essentially, what this means is that we have like terms in our expression. In order to add and subtract these radicals, we need to make sure that what is under the square root sign is all the same. If it is, then we can combine them. So in number 13, I have 5 root 2 plus 7 root 2 minus 6 root 2. Because they are all root 2, I can combine these three terms. I'm going to add 5 plus 7 minus 6, so that's 12 minus 6, which is 6, and then I leave the root 2 the same. In number 14, we have two different radicans here. I have a root 7 and a root 11. So we need to combine the ones that are like. So I have 10 root 7 plus 4 root 7. In that case, we have 14 root 7. 5 root 11 minus 6 root 11 would be negative 1 root 11 or minus root 11. And now I can't do anything more because root 7 and root 11 are not like each other. In our next type of problem, we are going to continue adding and subtracting these radical expressions, except we run into an issue because these radicals are not like, so we don't have like terms here. However, if you remember our previous lesson, we were able to simplify these. So I'm going to simplify this root 18. I'm going to find the biggest perfect square factor of root 18. In that case, it's root 9. So root 9 times root 2 is root 18. I'm going to simplify this to 6 root 2. Root 32, I'm going to simplify. Biggest perfect square factor is 16. So that would simplify to 8 root 2. And finally, root 72 has a perfect square factor of 36. We are going to simplify that to 6 root 2. And now you notice our last line, we were able to simplify each of these terms to a radical that all had 2, meaning which we can now add these the same way we did in the previous slide. 6 plus 8, 14. 14 plus 6 is 20. So our simplified answer is 20 root 2. Our goal for this one is the same as it was in the previous slide. I'm going to simplify this root 45. So this term will simplify to 9 root 5. Root 20. Find that biggest perfect square factor. So root 20 would simplify to 2 root 5. So notice how we have now simplified these two terms in which they have a radicand of root 5. And finally, root 245. Perfect square factor of 49. So we have like terms all the way through. 9 plus 2 is 11. 11 minus 7 is 4. So our simplified answer is 4 root 5. When multiplying radical expressions like we are in number 24, we are going to multiply the 3 and the 2. They are outside the radical. So 6 root 2 times root 6 is root 12. However, we need to make sure that we check to see if our radical can be simplified further. In this case, it can, because root 12 has a perfect square factor of root 4. That is 2. So I have 6 times 2 times root 3. multiply the 6 and the 2 here for a simplified answer of 12 root 3. In number 25, we need to apply the distributive property. 3 root 5 times 2 root 5, so 3 times 2 is 6. Root 5 times root 5 is root 25. Now I'm going to take this 3 root 5 to the second term. 3 times 5 is 15. Root 5 times root 3 is root 15. Now this root 25 is actually a perfect square, right? Square root of 25 is 5. So 6 times 5. $30 plus 15 root 15. Root 15 cannot be simplified any further. There are no perfect square factors of 15. And this is going to be our simplified answer. Don't make the mistake of adding 30 plus 15 and writing an answer of 45 root 15, because these are not like terms. We are done with this problem. In number 29, same concept. We're going to use the distributive property. 5 times 3 is 15. Root 3 times root 2 is root 6. I'm going to bring the minus sign down, distribute the 5 root 3 to the root 3. 5 times, there's an invisible 1 right here, so it would just be 5 out front. Root 3 times root 3 is root 9. Root 6 does not have any perfect square factors, so that is done. However, root 9 is a perfect square, so that's 3. Root square root of 9 is 3. I'm going to multiply these two together. My simplified answer, 15 root 6 minus 15. I cannot go any further because these are not like terms. And finally, last concept, rationalizing a denominator. So you'll notice that in this example, our denominator is a radical. We have root 2. We cannot leave a radical in the denominator. So what we are going to do is figure out how to get rid of it. To do so, we are going to multiply by the radical that is in the denominator. If I multiply the bottom, the denominator, I need to multiply the numerator by that same radical. Root 2 times root 2 is root 4, which is just 2. So notice when we multiply two radicals that are the same by each other, we just get the number that is under the radical. The top, 5 times root 2 is just 5 root 2. And our final answer is 5 root 2 over 2. And in our last example, again, we have a radical in the denominator, so we are going to multiply by the radical to get rid of it. So I'm going to multiply the bottom by root 6 and the top. So that will take care of the radical in the denominator, but let's see what happens on top. 3 root 2 times root 6. So I'm going to multiply the radicals together, so I have 3 root 12. Root 12, though, is not simplified. Root 12 has a perfect square factor. So I'm going to simplify that, right? Because root 12 will break down into root 4, root 3. Three times 2 is 6, so I have 6 root 3 on top over 6. Now because I have 6 root 3 on top, all divided by 6, 6 divided by 6 divides evenly into 1. So our final answer is simply root 3.